there everyone, welcome to Mindshop Studio. This is Chris. Today I'm going to show you how to make the game Snakes and Ladders on your MicroBit. It's going to be a 2-player game so you can play it with your friends, and it's going to be fun, I promise. Are you ready? Go ahead and fire up your browser to makecode.microbit.org and follow along with me. And it's good if you have a MicroBit. If not, you can always use the emulator. Let's get started. One thing about this game, it's a little bit more complicated than some of the other things we've done. So we need to take a minute to think about what we're going to do and how we're going to do it. So the first thing I think we need to do is decide where each snake and ladder will begin and end. Okay. Then we should think about our board layout. Now we only have 25 lights on our MicroBit. And so instead of doing the traditional snakes and ladder board of 1 to 100, I decided to just do 1 to 25. We should think about how are our pieces going to move on the board. You know, in the normal game, they start in the bottom and then they move up, right? And so we're going to follow that kind of pattern. We want to move the players, and then after we move the player, we have to check, are they on a snake or a ladder? So we have to have a way of comparing the player's location with our snakes and ladders location. We need to check to see if the game is over, to see if they've reached this last spot. Therefore, we need to keep track of each player's location. We're also going to keep track of whose turn it is. That way you can only play when it's your turn. Now to start with, I made a list of snakes and ladders. And my ladders are going from space 3 up to space 7. Ladder number 2 goes from space 8 to space 14. Ladder number 3 goes from space 15 to space 22. And then I have 3 snakes, so going from 24 to 9. I like that because it's the next to last square, just enough to mess with you. Also from 21 to 13, and then from 18 to 11. So my snakes are kind of up there. Now, players are going to start down here, which is 0, 4, and that's going to be square 1. And then when they reach up here, which is 4, 0, the game will be over, and that's square 25. So essentially, I had to map out the number, the square number, with each location of the LED. And I made a little map of that. I actually drew it out by hand so that I could easily keep track of that. Another thing, when the players move, they're going to move in this S-like fashion. So they're going to start off down here and move this way, and then go up and come this way and up and that way, and so on and so on. We're going to have to roll a dice. I've decided that player 1 will be the A button and player 2 will be the B button. And player 2 is going to blink. It's not blinking on this one, but player 2 is going to blink. And then if we hit a snake or a ladder, we're going to show a picture of a snake or a ladder. All right, the first thing we want to do is create our variables. So the first variable is going to be dice. We're going to have to roll a dice. We only need 1 dice. Then we'll have a player 1, which is going to be the sprite. Sprites are in game function. It's going to be the sprite, the little LED, that represents player 1. So of course we need a player 2. Now I'm going to have a variable called player. And player will either be 1 or 2, and that way it will just keep track of which player is taking their turn, and that way I know which player's turn is next, and I can keep players from cheating with this variable. Now I'll make a variable called location. Location check. It's kind of long, but that's what it's going to be. We're going to use this variable to check the player's location against the locations of snakes and ladders. And then we actually need P1 location and P2 location. All right. So when we start, we want our players to be at the first square, which is 0, 4. So we'll create our sprites there. Go to Game, and we get this create sprite at, and then in variable. So I'm going to set player 1 to create sprite at 0, 4. And we will do the same thing with player 2. And then we're going to set our locations. Player 1 location, but we don't want location. That's right. We want location to be 1. Now, it's important that you set location to 1 because that means that this first square is 1. If you set it to 0, then your last square ends up being 24 instead of 25, which messes things up. Plus, if you don't have that set at 1, it'll throw all your snakes and ladders off. We'll also set player 2's location to 1. I'm going to set my player variable to 2. And the reason I'm setting it to 2 is because I want player 1 to go first, and I'm going to check whose turn it was, who just took their turn to see whose turn it is now. So if I set it to 1, that means player 2 will actually start. So we have to set it to 2 so player 1 can start. One more thing I want to do, there's a cool block in game here. Change this from sprite to player 2. And we're going to set blink to 200. And so you won't notice it when the 2 players are in the same space. It won't blink because player 1 doesn't blink. But if player 2 and player 1 are not in the same location, it will be very easy to tell which player is in which location. You don't need the forever block. All right, now we're going to use functions. So this function is going to be move. You see it pop the function right there, which I think is kind of funny. So in move, the first thing we're going to do is check who's taking their turn. Comparison block, and we'll get a variable player. So if player is 1, then we'll move player 1. Else, it's player 2's turn, we'll move player 2. All right, and here's how we're going to use some built-in MicroBit functions to our advantage. So when you create a sprite, they're automatically heading to the right. So I create a sprite here, it's pointing this way, okay? They're automatically going to the right. What we're going to do is when we reach the edge, we're going to turn left 90 degrees. That'll point us up. And then we move 1 space, and then we're going to turn left 90 degrees again and come back. And then when we get here, we're going to do the opposite. We're going to turn right 90 degrees and turn right 90 degrees again. This to player 1. So we're going to look for where is player 1's X. And if player 1's X is at 4, then we're going to turn 90 degrees. And that is also in game. Let's see. Player 1, turn left 90 degrees. And if player 1x is 0, then we want to turn right 90 degrees. And what's great about this, it's actually a very simple solution. And because it hits that first square that's 4, and it turns 90 degrees, and then it moves up, and that square is also 4. And so it turns again without us having to do anything extra. I really love how this works. And so for all other cases, whether x is 1, 2, or 3, we don't care. We don't need to put any conditions in there. And now I'll duplicate this for player 2. Just change everything from player 1 to player 2. Okay, so that takes care of how our players need to move around the board. Now let's create a function to check the player's location. And we'll call it location checker. So this is where we check to see if we're on a snake or a ladder. Comparison block. And we're going to use this location check variable now. And we're going to say if location check is 3, because my first ladder is at 3, then we're going to show a ladder. And I want to make sure the ladder is seen, so I will pause for 0.2 of a second. Oh, you know what? Why didn't I think of that before? It's amazing what you think about sometimes while you're doing something. We're going to create a function called snake and a function called ladder. And I'll explain why in just a second. Yep, I just figured this out right now while making the video. So essentially, we need to draw the snake and the ladder over and over again. And I thought, you know, why do I need to do that over and over again? I can just make those functions, and then the functions can do it. You just have to call the function. Close enough, kind of an ass, whatever. So now we can actually just call ladder, and we'll show a ladder. Now we need to check and see which player is taking their turn. So we'll put another if here. And so we'll check and see if it's player 1 taking their turn. So if player equals 1, and then we'll take care of player 1. We're going to need an else there. So we actually need to delete the player and then recreate them. Otherwise, we'll have the same thing twice. So we're going to delete player 1, and then we will set player 1 to create sprite, add 3, which is a new location. And we also need to set the direction of the sprite, which happens to be opposite of where it was before. So we need to turn it around 180 degrees. So I go here and say player 1. We can turn it because we're turning 180 degrees. And now we need to set our player's location. All right, and now we just need to duplicate all of these for player 2. And so I'm going to duplicate this whole set just so I can pull this out. Put it in my else, and we'll change all this to player 2. And then a really important thing is we need to tell it to blink again because we deleted that original sprite that was blinking. We need to tell it to blink again. To set blink to 200. All right, and now we're going to continue to do this for all of our snakes and all of our ladders. So 8 equals 14. And then we need one more condition to check to see if the game is over. And this time, we can't say it equals to. We have to say it's greater than or equal to 25. So if the player wins, we're going to clear the screen. And then we're going to show the string player wins. So P1 wins. And then we'll end the game. Where's the game over? And we need to set the score actually before we do that. So we'll get a set score block. We want to put it there, and we'll set the score to the player's location. So this would be P1 location. And the reason I did that is because if you use the game over block, it shows a score, and if you don't set the score, it'll just say score 0. And I think it's kind of silly if you end the game, but your score is somehow 0. And this time we'll say P2 wins. And we'll set the score to P2 location. Awesome. We're almost done. Now we just need to make the players roll the dice. So again, button A is going to be player 1. So let's do that one. And we're going to start by making sure that it is player one's turn. And so we're going to check the value of player. And so we're going to say that if player is equal to 2, right? Because what we're going to do is when player 1 rolls the dice, we're going to set the value of player to 1. When player 2 rolls the dice, we'll set the value of player to 2. So what we'll do is if player variable is 2, then it's player 1's turn. If player variable is 1, then it's player 2's turn, at least at the start of their turns. Makes sense, right? All right. And we will get a set. And we will set dice to a random number from 1 to 6. And we will set player to 1. We're going to show the number that was rolled. We're going to change the player's location, one location, by the dice, which will take what the current value of P1 location is, and on the first turn, that's 1, and then it will add whatever the value of dice is to that number. And so we just keep adding dice. Now we're going to do a little for loop. And for loops say for index from 0 to 4. And what we're going to say is actually from 0 to dice. But we can't go 0 to dice because dice goes from 1 to 6. So we have to say dice minus 1. We have to put in a little math. And now we're going to move the piece. Here, move by 1. So we'll move player 1 by 1. And then we need to make sure, check its location with the move function. And to make sure that we can actually see the piece moving, we will pause 1/10 of 1 second. We don't need an else because if it's not player's 1 turn, we don't want anything to happen. So we'll just keep that. Okay, and then the last thing we need to do is set our tracking location check, and that's going to be equal to player 1's location. And we want to do that after we move the piece, right? We move the piece first, we do the little animation of moving, and then we check for the location. And the reason why I didn't do any animations for moving the piece if they hit a snake or a ladder is it was kind of messy. Okay, and so now we've done this, and then we can call location checker. Just that simple. And once you've done it for player 1, you just duplicate. What just happened? No, don't do that. That's funny. All right, and it's all ghosty. Got to change this to the B button, and then change everything from player 1 to player 2. All righty. Let's test it out. So we'll try rolling player 2 first. Nothing happens. Great. Okay. Now let's try this. Ooh, 6. Wow. And look, there's the blink. So now we'll try player 1 again. Player 1 cannot move. Player 2, 4. Okay. Player 1, 3. Player 2, 5. Oh, they're in the same space. 2, 1. 5. We haven't hit a snake or a ladder yet. Oh, there's the big snake. And you saw the snake come up on the screen, and now you see the player has moved down here. And bam, player 1 wins. Awesome, man. I have to say, I made this game with Kyle because Kyle wanted to do some MicroBit stuff, and I wanted to find something that would be interesting and fun after we finished it. And I thought this was actually a really great application for MicroBit because you've got such a simple display. There isn't, in my opinion, a lot that you can do with it, but if you use your imagination, you can come up with some pretty cool things. Well, guys, there you have it. Snakes and ladders on the MicroBit, as promised. I hope you enjoy it. I hope you have a lot of fun playing snakes and ladders with your friends. Remember, put the app on your MicroBit, put a little battery on the MicroBit, and take it out with you. Play it with your friends someplace else. You don't have to be tethered to the computer all the time. That's it for me, and I'll see you next time. Goodbye, everyone.